We are told Sally plays 2 games against Martin. In each game, she could win, draw, or lose. In each game they play, the probability that Sally will win against Martin is 0.3, and the probability that Sally will draw against Martin is 0.1. We need to work out the probability that Sally will win exactly one of the 2 games against Martin. And this question is worth 3 marks. Okay? So, the first thing we can do is we can say the probability she wins plus the probability she draws plus the probability she loses equals 1. And since we have the probability of winning is 0.3 plus the probability of drawing, which is 0.1, plus the probability of losing equals 1, 0.3 plus 0.1 is 0.4. So we have the probability she loses plus 0.4 equals 1, and therefore the probability she loses equals 0.6. Okay, so 1 minus 0.4, and you get that by subtracting 0.6 from either side, 0.4 from either side, like that. Okay, so we will just write here the probability she loses is 0.6. Okay, now to find the probability that Sally will win exactly 1 game, we're going to draw a tree diagram, okay? And this will help us, okay? So we will say 1, 2, 3 for each of the 3 outcomes. Then for each of these, we have 3 branches, like this and like this. So this is the first game, and this is the second game, okay? So we have win, draw, lose, win, draw, lose, win, draw, lose, and finally, let me just make this one a bit bigger so we can actually work with it. Win, draw, and lose. So let's populate it. We have 0.3, 0.1, and 0.6, 0.3, 0.1, 0.6, 0.3, 0.1, and 0.6, and finally 0.3, 0.1, and 0.6. This is a bit confusing. Let's just, in a different color, draw a brief line just to break these 2 apart. There we go, like that. Right. So, the probability she will win exactly 1 game is, so P exactly 1 is, she will win her first game, but she will draw or lose her second game. So this is going to be 0.3 times 0.1 plus 0.3 times 0.6. Okay, so those are the first probabilities. Or she will draw her first and win her second, or she will lose her first and win her second. Okay, plus, so because we're doing with or, we will use the plus operator, plus 0.1 times 0.3 plus 0.6 for losing times 0.3 for winning the second one. Okay, so just to recap, following the cursor, either she wins the first one and then she draws the second one. So this is 0.3 times 0.1, which is our first one here. The other option is she wins her first one, but she loses her second one, which is 0.3 times 0.6. So in this case, she has to win the first. Well, she has to draw or lose the second one because she's won the first. Now in the other two, if she draws the second or the first game, she can win the second one. So this is 0.1 times 0.3, which is why I've done it in this order. Or she can lose this one and win the next one, which is 0.6 times 0.3, which is this order. Okay? So for all the numbers here, the first one in the operator and the multiplication is the first game, and then the second number is the second game. What we can do now is we can sum these probabilities by hand, okay? So 0.3 times 0.1, well, this is just going to be 0.03. 0.3 times 0.6 is going to be 0.18. 0.1 times 0.3 is again 0.03. And 0.6 times 0.8 is 0.18. Adding these, we have 0.18 plus 0.18, that's 0.36. 0.36 plus 0.03 is 0.39, plus 0.03, that's 0.42. 0.42. And we'll check this with just some column addition. So 0.03, 0.18, 0.03, and 0.18. First thing to do, 3 plus 8 is 11, plus 3 is 14, plus 8 is 22. So 2 here and carry the 2 here. 1, 2 plus 2 is 4, like that. Bring the decimal point. 0 plus 0 plus 0 plus 0 is 0. So we have 0.42 as our correct final answer. So this question is worth 3 marks. The first mark comes from at least one stage of appropriate multiplication, okay? So in our case, doing 0.3 times 0.1 or 0.3 times 0.6 for the first case, okay? So that just gets us our first mark. The second mark comes from a complete process, so all of these, so getting all the way up to here, and getting to this stage is your second mark. And your third and final mark comes from summing these correctly to get to 0.42 as your correct answer. So as your final answer.